Hello, everyone. We have a great webinar for you to discuss the 4 common pressure calibration pain points. My name is George Rivera. I'm an engineer and sales manager for T Equipment. Joining me is Bob Krebs, category manager for Fluke. Before turning it over to Bob, and while we wait for some late joiners, I had a couple slides to talk about our little background on our company. I just want to make sure, Bob, are you there? Can you unmute yourself? Just want to make sure.
Yep. Hey, George, how you doing?
Good, and you can hear me fine?
Yep, really good.
Okay, thanks. Like I said, I just wanted to go over a couple slides. One housekeeping thing, we already had a chat question about certificate of attendance. If you need one, just come on the online chat or shoot me an email at the sales team address there on the page that you see. And we can get you a certificate if you need something for work. So our company is over 16 years old, and we've become a very large stocking distributor. We really do take to heart the slogan, buy from people, not just the internet. And we have a qualified staff here to help you. As you can see from this slide, we're an international and national distributor, and we cover the needs of quite a wide variety of customer types on the left side. And on the right side gives you just a sampling of some of the product categories of instrument types that we carry, in total over more than 500,000 products. And on this slide, very quickly, you can see we've invested very heavily on making our website a great resource. On the left side, you could see the filtering capability by specifications, depending on the department or category that you're in, so you could search for what you're looking for faster. On the right side is a little thumbnail screenshot of an internal portal that we use to provide a better customer service experience. And we're also constantly enhancing the front-end website and internal systems to continue to give a better experience. So that's really all I wanted to cover. And now let me just turn it over to you, Bob. Thank you for joining us, and look forward to your presentation here.
All right. So I'll just get my screen up.
Yep. Hang on a second. Let me make presenter. There we go.
Okay, I see that. Let me see if I can get my program here. Okay. Can you, George, can you see the screen there?
Yes, yes. And
okay.
If anyone has any questions throughout the, forgot to mention, if you have any additional questions, use the chat feature in the browser.
Yeah, and there should be time afterwards to do some question and answer as well. So, okay, well, let's talk about pressure calibration today. My name is Bob Krebs. I'm actually not a category manager, although thanks for the promotion. I'm the product specialist for process tools here at Fluke Corporation. So Fluke's been in the pressure calibration market for over 20 years now. Personally, I do a lot of tech support for high-end calls, and I've gotten a lot of feedback from customers regarding issues that they have with doing pressure calibrations, issues they've had. That information, I take that and I translate it over to the engineering group and offer them VOC, voice of the customer, back. So that helps us develop new technology, trying to make the customer, the technician out in the field, make their job easier and more efficient. So from that feedback, I've seen quite a few pain points from customers, and the 4 biggest ones that I've seen are one, leaks while doing a pressure calibration, causes of the leaks, how to mitigate the effects of that. That's probably the #1 issue that I've seen. Second, documenting those pressure calibrations. How can you document a pressure calibration when you've got your hands full of equipment, trying to do, set those set points, write down those measured values. Third is trying to generate, accurate pressure set points, and go into a five strategy test point, for example, trying to get that information, to write it down, get the skills to use the tools properly. All that's really important. And finally, pressure switches. Those things they're tough to learn how to calibrate. You have to be able to, get a reading, and then you need to repeat that test to make sure that you've got those the right pressure to set and reset that switch. So let's take a look at that first pain point, pressure calibration and leaks. So, any kind of leak in a pressure setup is going to cause a lot of issues when you're trying to do a calibration. Trying to get a perfect seal, that's tough. There's always going to be some kind of leakage in there. The only time I've ever seen a perfect pressure calibration is when we do a video, because that way you can test and retake and everything, but that's not realistic for the field. So trying to mitigate those issues, trying to, a small leak is probably going to be the best you can get. Hopefully sometimes you can get a really good calibration. And the main thing, is trying to hold that pressure stable to get that reading, to record that if it's a milliamp output on that pressure transmitter, trying to get that pressure to the right set point, leave it there, and write down that output. That's the key. Things like damping, that can cause even more problems. So it's hard to get that in a perfect situation. Along with that, you're trying to figure out what kind of test hose to use, what kind of fittings to use. It changes depending on where you're testing, what the application is. Trying to source the pressure. You've got different types of, you got pumps, you got manual, automatic. You've got a regulator with a tank you might need to use, or maybe hydraulic fluid. It depends on the application, what you're going to use for your pressure source. So the first thing you need to do, of course, is check your setup. Make sure you got the right hoses and connectors. There are connectors out there with hoses that you don't need to use wrenches. You don't have to use the thread seal tape. You could just screw things down and you're good to go. And that's the goal, to try and make it as easy as possible to get your connectors going, because that's where most leaks are, right? It's right in the hoses and connectors. If you do have to use the thread seal tape, make sure you wrap enough tape around there. Before you make connections, you have to make sure you remove the old thread seal tape, wrap it in the right direction. You don't want to wrap it the wrong way, because then it's going to come undone when you try and connect it. And there's also the option of using a liquid thread sealant as an alternative. So, getting the right setup. The best way to do the setup that I've heard from the folks out in the field is, do the setup before you even go out in the field. Get on your test bench, make sure your hoses are all set up, make sure test it with a pressure transmitter or gauge. Make sure you don't have leaks for very little. You want to make sure that when you get to that pressure that you're going for, let's say you're going to 300 psi for your field, make sure you pump the pressure up make sure you got that pressure at the right location and it's steady. If it's not holding, then you have to start troubleshooting. There's a couple different options out there. I've seen really good results just by having a little bit of liquid soap in a spray bottle with water, maybe a 10% mixture, and that seems to, it'll bubble up if you have a leak, whether it's on a fitting or hose connection. There's also a commercial version of it's called Snoop, which lets you know again if there's leaks. So, another way of trying to lessen the issues is have like a nitrogen bottle, and it's got a regulator on it, so you can actually try and hold that pressure steady. And that seems to work really well. It's kind of clumsy, you got this big tank you got to carry around. It works great until the tank empties, and then you have to deal with something else. So, and of course, there's danger issues as well. But the alternative is to use one of the modern pressure calibrators with automatic pressure regulation. That's one of the new things that's out there now. So, what's required when you go out to do that calibration? There's all kinds of calibrators out there. Those multifunction calibrators are nice because they've got a lot of things built right in. You can, do pressure calibrations, temperature calibrations, 40-20 milliamp, loop power, all that stuff's included in a lot of those calibrators. So having a dedicated, especially for pressure, having a dedicated calibration tool with a built-in pump, that lessens the amount of, fittings and tools that you have to carry out there with you. Some have manual, some are electric, some are even automatic. So, and then of course you want to make sure that the calibrator you're using is accurate. You want to make sure that the temperature, or excuse me, make sure the pressure range of that calibrator matches the pressure, upper range value that you're calibrating on that end device. So, if you're using, let's say, 300 psi calibrator for a 100 psi transmitter, it's probably too much. You might need to use a pressure module or use a pressure calibrator that's in the range of the device being tested. So remember, if you're calibrating 50% of the range of the sensor being used as your source, you're only going to get half the accuracy. So you got to look at all those factors when you're doing a calibration. Pressure calibration is tough. There's lots of things to remember. So then you got to look at documenting. So documenting those calibrations, that's another challenge. Okay, you have to go out there. If you're, if you got a manual worksheet, it's going to have written on there, what's your strategy, what's your pressure range, what's your percent of accuracy you need to have. All that's important, but then you also have to worry about all the equipment you're taking with you. You got a pump, maybe a gauge, how the heck do you calibrate and document those results with all the stuff in your hands? So, there's ways of getting around it. Some of the tools have magnets or hanging straps that lets you, put the calibrator somewhere to do your work, and then you have to write this stuff down, or get yourself a documenting calibrator. With the documenting calibrator, it automatically captures those results digitally in the device, and you don't have to worry about having a pencil, pen, paper, whatever with you when you're out in the field. So with the modern documenting pressure calibrators, now you've got one tool that does quite a bit of stuff for you. You've got automatic testing, which lets you do all the calibrations that you need to do, all the parts. So the first part of doing a calibration, is the initial test, the as found. So you go out, you know, do your test, see if you've got good results. If the calibration is in specification, then you're done and your calibration's complete. If it's out of spec, then you have to make adjustments. So you make your adjustments. Now you have to go back and retest, and that's of course called the as left result. One thing nice about having an automatic documented calibrator is it does all this for you. It documents the as found. If it's out of spec, it lets you do the adjustments and then retest, and it takes those as left results, stores that data in the calibrator, and then you can upload it to your software after that. A lot easier than carrying around that piece of paper and pencil. So, you know, one advantage again about having software with your document and calibrators, you can create configurations for every instrument you've got in the field and store that in the software. So you can download those tasks to the calibrator. You can bring up that task to do the calibration. So you know, some of the calibrators always also have templates to help you predefine what kind of test you're going to run. But things that are important, you know, in that calibration are, you know, your upper low range values, what your inputs and outputs are going to be. And then if you notice on the slide here on the very bottom, you know, you want to be able to put in the tolerance for that calibration. You know, every company has different requirements, whether it's an accuracy of 0.2% listed here up to, you know, 1% or 2%, whatever it is. You also want to be able to plug in your test strategy. You know, we talked about, you know, doing a test for different levels from 0 to 100%. You know, 3 up, 3 down, or 5 up, 5 down, whichever. And then of course, you know, is your pressure transmitter going to be linear, or is it a flow transmitter where you actually might need to use a square root value? So all those things can be predefined in software, or if you manually set it up in a calibration, you could do it on the calibrator itself. Another important feature about a documented calibrator is being able to document logged readings. Let's say you want to do, you know, check the pressure of a device over a period of time, you know, to check for spikes, check for drops. You can do that with the documented calibrators. You can also use wireless communication, as shown here, with such as like Fluke Connect. You know, send that information to a phone. You can record that data, send it to another location. So being able to document logged information is also a key feature in a lot of calibrators out in the field now. So let's take a look at the benefits of using a documented calibrator. Okay, we just talked about, you know, hey, you don't have to write down those measurements. You know, writing down measurements can cause all kinds of issues. You know, that eliminates transcription errors, eliminates errors from, you know, passing that calibration sheet to somebody else, and they have to read your writing. My handwriting is horrible, so if someone tried to read what I wrote down, there's a good chance you're going to have an error writing that information onto a calibration report on your computer. So having that information digitally stored in the calibrator and uploaded automatically to your software, that's key. Very important to have. Having that calibration management software we talked about, you know, being able to upload those test results or download tasks for a technician to run. You know, you can set up routes. Let's say you have, you know, you have a work area where you've got 5 transmitters. You can, you know, download a set of tasks or routes for that technician to go out to those specific devices do the calibrations and bring them back. So it saves time, saves money, optimizes the time and work for that technician, lets him do his job a lot easier. So we talked about test points. Industry standards. It depends on the company. I get a lot of calls from customers saying, "Yeah, I do a 5 up or maybe a 5 up, 4 down test," and that's what that is basically, testing at 0% of span, 25%, all the way up to 100%, and then going back down. So you're checking the up and down values, verifying that everything's accurate at each test point. So those strategies include both ascending and descending. Lets you check, do I have linearity in that test? And if, depending on the requirements for that customer, you may, see some out of spec issues, not just in the top and the low end, but in between. Being able to document that information is very important for checking the history of a device and what it's doing. So, doing those multi-point tests, when you're doing it manually, you've got a hand pump, you've got to hit that test point. Generally there's going to be a fine-tuning veneer included on that pump, whether it's a hand pump or a built-in pump on a calibrator. You need to get as close as you can. You have to do your fine-tune adjusting, then you have to recheck to make sure that you're staying on that level before you take the recording. You also have to watch out you don't overshoot. A guy with a strong hand pump, it could go beyond the range of that device, and too much pressure, there is a chance you could damage the transmitter or even the test tool. So there's pressure relief valves that can help mitigate that issue, but those are things you need to think about when you're doing those multi-test point strategies. So let's take a look at a couple of tricks you can do. Okay, again, first thing you want to do is test your setup before you go out. Try to resolve any leaks. Get a hand pump that matches the application. There's lots of pumps out there. Some go to, they're low pressure pumps, some are medium pressure. Then you got the, the high end pumps that go up to 10,000 PSI, which are hydraulic. Make sure you have the right pump for the right application. Make sure that you use the veneer properly. Now, I've seen a lot of times, and I've done it myself, you pump up to the pressure you want, but you're a little bit too high, so you turn the veneer, but you didn't center it first. So now you have to retest because you got to center that veneer and give you some leeway either direction. And you want to retest that every time you go from one test point to the next. It's always easiest to take the transmitter out of the process and even, put it on a test bench. You've got, calibrators that can do automatic tests on the bench, but that's not always, the most efficient solution. We've got the new Fluke 729 automatic pressure calibrator. You can take that in the field with you and do your calibration in the field, giving you the ability to automatically, it automatically has a built-in regulator, pumps up to each pressure test point, takes the readings, and of course it documents and uploads to software. So then we got pressure switches. So pressure switches are, again, it takes a bit of practice to get good at testing pressure switches. You have to be able to slowly pump the pressure up to the set point and then slowly bring it back down to the reset. And you need to test it a couple times to get repeatability. That verifies that you have done the proper calibration of a switch. So that's the big challenge. So most switches, you see the sample here that we got hooked up to one of our 718 calibrators. It's a, it's a 3-wire switch. It's, normally you're going to see like the black wires are common. Then you have 2 options. You can either have it normally open, which might be the red wire, normally closed, which is green in this case. Normally you just use, one set of switches. So you have normally open or normally closed. So this drawing kind of shows, whether your switch is normally at the reset state, which is a relaxed state, and that's either going to be open or closed. And then you pump the pressure up till it hits that set state, and that would be the opposite. So let's say we start out where the switch is normally open, pump the pressure up, goes to the set state, then the switch closes. So that is normally what you can adjust. There's probably like a screw on there, or a Allen wrench, whatever, that you can adjust what that set state is. So there's a, between that set state and the reset state, there's something called the deadband, and that's the difference between the two pressures. So you need to, pump the pressure up. Let's say it's normally open. You pump the pressure up, it closes. That's the set state. You release the pressure, then it goes to the reset, and then the difference in those two is your deadband. And you can see in the example here, you got the open state. You pump the pressure up. In this case, it was inches of water. Went from up to 290 where it closed, so it opened to close, and then you look at the deadband, which was the difference in those two values. So that's the those are the 3 states, and the calibrators like the 718 will allow you to look at those 3 positions. But again, you need to do that test a couple times. You need to get repeatability, at least 2, maybe 3 times, just to make sure that you've done that calibration properly. So start with the set state, or pump the pressure, hit the set state, and then relax the pressure to get reset. And then of course it shows you the deadband. So one thing cool about having an automatic pressure calibrator is you just define what you want the set point to be, what you want the tolerance to be, what your minimum and maximum deadband are, and then you just press go. And that makes it nice. So you just come out there, and you can see in this application, you start the test, it's normally open, it pumps the pressure up, hits the set point, goes to reset, and then shows you the deadband. So really efficient way to doing it. And the cool part about this is it slowly steps that pressure up for you and gives you accurate results. And don't forget, it's going to document these results for you, and you can save that to software. So let's take a look at those 4 different pain points. Okay, the first one, again, pressure leaks. Make sure you debug your setup. Use something to mitigate pressure leaks, like a nitrogen bottle and regulator, or use an automatic regulating pressure calibrator, which automatically does all that for you. Secondly, you want to document those pressure calibrations. If you have an automatic documenting calibrator, it's going to do all the hard work for you. It's going to take those as found, as left results, document it with no human error involved, does the whole thing for you. Being able to, the third one, again, automatically generating pressures to the different strategy test points. Going into a 5-point or a 5 up, 4 down test, you could take a job could take 20 to 30 minutes to do, take it down to 3 minutes. So it's just a lot easier to do that way with automatic pressure calibrator. And finally, doing those switch tests. doesn't take 10, 15 years of experience to do this with a hand pump. It's got a built-in routine with the automatic calibrator, gets the job done for you. So those are the pain points. Think about, getting a nice hose kit with self-sealing connections. Get the right test pump, and think about, an automatic pressure calibrator like the new Fluke 729 that will help eliminate those pressure test pain points. Thank you. Go ahead, George. If there's any questions, be happy to answer those for you folks.
Yeah, I'm looking right now. Here's a question from Joseph. Is there any normal value of hysteresis for a pressure switch? Some percentage of full scale or full range, or some other relationship?
Well, it's, a lot of switches don't give you a lot of options. I mean, most switches that I've seen just give you a set point that you can order it that way. You can make adjustments to where that closing or opening point is, but there's not a whole lot of other adjustments I've seen, like for deadband, or for the where it sets and resets. So you need to check with the manufacturer. Of course, the cost of the switch may allow you to make other than just the set point adjustment. Any other questions? George, I'm not hearing you.
Just one other question. On the pressure calibrator, for the pressure range, can you use a high pressure? What's the lowest that you would recommend? So they didn't give an example, but I guess if you have like a 5,000 psi calibrator and you're trying to calibrate something that's 50 psi, that's not ideal. I don't know if you have a rule of thumb. I could give my own, but I'd rather hear it from you.
Yeah, it's it's a good question. For we've got the automatic pressure calibrator, the 729, and it's got a maximum pressure pump that goes up to 300 psi. So obviously it won't go higher than that. So if you're up to, let's say, 5,000 psi, you can still use the calibrator to document the test results. But what you'd want to do is get yourself a pressure module that is most closely pressure range to the device you're testing. So we've got 50 different pressure modules. They're called the 750p pressure modules. And what you'd want to do is plug that pressure module in to the 729. The 729 is still going to be able to record the test results, but it's going to disable the internal pump, and you're actually going to want to use an external pump. For 5,000 example, you're going to want to go with a hydraulic test pump that's going to take you up to 10,000 psi. But if you're only going up to, let's say, 3,000, then you could use the 700. It's like it's one of our FCal. It's a foot pump, and that I think it's HPP or something like that. But again, you want to make sure that the sensor that you're using is as close to the range that you're calibrating as possible.
Thanks. Good answer. I don't have any other questions, but guys, if you think of something, or if you're watching the recorded version of the webinar online, feel free to contact us. There's all the information there, sales team at T Equipment, or our phone number. I do post it. We have, I created a part number on our website called IWH course. If you search our search box, the recorded webinar will be there, as well as the slide deck that Bob presented, as well as from other webinars that we've done, and other interesting app notes and things. And then everyone that's attending will also get a copy of it as well. Oh, I got one more question for you, Bob. Well, it's not entirely clear. What's the difference between the 729 and the one showing?
Don't know which one's showing.
Yeah, we'd have to go back. Sam, I'll email you separately. We'll go through that, whatever your questions are.
Was the previous slide, did you show a picture of a 754 maybe on there?
Yeah, could have been.
Well, we've got two major documented calibrators. We got the 729 and the 754. I'll talk about those real quick. So the 729 is specifically a pressure calibrator. That's all it does. It does it really well because it's got that built-in pump. It's got a built-in reservoir, built-in controller, so it automatically does pressure calibrations. It's got heart, and it also talks, it can communicate with our DPC Track 2 software, or like ProCal V5, the enterprise versions. The 754, that is multifunction, right? It doesn't have a built-in pump or a regulator. You have to use an external pump with it, but the 754 calibrates everything, right? It does pressure, does temperature, does frequency, does everything. And so that's the main differentiator between those two calibrators. It depends on what your application is and what your needs are. If you want to do the best possible pressure application out there, get the 729. If you've got a bunch of different things you want to calibrate, then and you're willing to use a hand pump, then go with the 754.
And 729 follow-up question, the max pressure is 300, right?
Yeah, well, there's actually 3 different models. We've got a 30 PSI model, a 150 PSI model, and a 300 PSI model. So again, decide what pressure range that you want. If it's something that falls out of that range, then like I said, we've got pressure modules that you can plug into this guy, and those range anywhere from 1 inch of water, really small pressure, all the way up to 10,000 PSI.
All right, that's all the questions we have, and thank you again for attending. And like I said, everyone will get a copy of the presentation and the link to the YouTube, or you could look it up on our website. Bob, thanks so much for your time, and give us a call or contact me directly if you have anything that comes up after the webinar. Thank you.
Thanks,
Bob.
George. Yep.
Bye.
Bye-bye.